Hello there, lovely ones. So we're working through the calculus questions from Mathematics Paper 1, May 2022. It's the IEB Maths paper, supplementary. And so these two questions are going to be our first derivative questions. The first one's really nice and easy. The notation they want us to use is this one. How do I know that they want us to use it? Because they put it over there. But it means the same thing. We're still just finding the first derivative, and that's going to be 6x to the power of 2 and minus 4. And the way I got that was 3 times by 2 gives me 6. 3 minus 1 gives me 2. And of course here I have a constant, which means, x to the power of 1, which means it turns into my constant over there. 2 marks, it should take you 1 minute to do, so that's quite nice. And then the next one, I like giving you questions like this because it requires a little bit of out-of-the-box thinking. Let's actually start by first changing the exponent to be 2 over 5. And I know it's going to be 2 over 5 because I know my laws of exponents. So if I had the square root of x to the power of 3, it would become x to the power of 3 over 2. Or in this case, I've got 5 root x to the power of 2. The 5 becomes the denominator, and the 2 is the numerator. And that's going to be a really common thing that happens in most exams. So good to note. The other thing that we like testing is, do you know that when you bring the denominator up to the top, you've got to have it to the power of the negative, whatever it is. Now it's much easier to do the first derivative. We're still using the same format as before. So now it's going to become negative 2 over 5. The reason it becomes that is because the negative 2 over 5 multiplies the 1. And then I've got x to the power of minus 7 over 5. How did I get the minus 7? Well, I went minus 2 over 5 minus 1, which is the same as 5 over 5, and that gave me minus 7 over 5. So still 2 marks, but still okay. Now for this particular question, we're looking for what values of x is the function increasing. And this is where we're going to look at the derivative of this cubic function. Remember, the derivative will give us a parabola. The parabola could look like that, or it could look like that. And we'll only know once we found the derivative. Where the derivative is underneath the x-axis, that is where the function would be decreasing, the original function. And where it is above the x-axis, that would be where the function is increasing. So I've now done the first derivative, and as you can see, it is a parabola. We can also see that the a value of the parabola is negative, so we are not looking at this kind of shape, we're looking at that shape, because when a is negative, that's what happens. We need to find the x-intercepts of the derivative, which means we're making it equal 0. And then we're going to factorize. And the way we do that, well, the way I'm going to do that is by taking out negative 1 as a common factor, just to make my life easier. I find it easier to then factorize. We're going to we are going to divide both sides by negative 1 to get rid of that negative 1. And we come to a point where x either has a value of 1 or x has a value of negative 3. If we're looking back at this parabola over here, we're saying that this coordinate there is 1, and this coordinate over here is negative 3. And where our function is increasing is above the x-axis. So that means that it is increasing between the values of negative 3 and 1. And the question is, why does it include those stationary points? Because at those stationary points, even though they call it that, we are both moving up and down at the same time in equal measure. So we put the less than or equals to sign, or more than and equals to in this case. And just in case you forgot, these coordinates over here are actually the x-coordinates of our stationary points, with the y-coordinates being somewhere else. So we'll put that there. And that's enough from me for now. Much love.